So I guess I'll pass it off now to Cody.
Thank you. So with respect to grasping, in terms of computer vision, there are pretty much three problem areas that we have to solve with computer vision. That would be object recognition and localization and your 3D pose estimation. These three tasks need to be completed in order to effectively manipulate objects, as well as finding the objects that you want to manipulate within a scene. Most of the approaches for stereo images require that the objects are textured. Objects that are difficult to handle are transparent objects, objects with high specularity, and objects that are just devoid of texture. So we, in our lab, have developed a new shape descriptor that we are going to try out with a shape-based approach to solve the above three tasks. Using this shape descriptor and in conjunction with a 3D library, we hope to be able to perform the above three tasks. Here's a quick overview of how we would perform object recognition, localization, and pose estimation. So you would say you have this teapot as your target object, and you would first extract a shape descriptor from this object, and you also have in your library of shapes, you have this teapot. From this teapot, you would also extract many different viewpoints, and for each viewpoint, you would also compute a shape descriptor. You would calculate some distance metric between the shape descriptor extracted from the 3D model and your image model in order to come up with a hypothesis as to the correct pose, as well as to the object's identity in general if you have many objects in your 3D model database. So you can see as the shapes match, you can recover the pose from the view that you've generated. With the PR2, that allows us to invoke active vision, where we now have a manipulator that we can, if we have high uncertainty in the objects, if we aren't quite sure what we are looking at and would like to get a better view, we can manipulate the camera in order to minimize the uncertainty, gathering more evidence by moving around the object, refining our hypothesis space until we find some geometric consistency among all the hypotheses. So that is our goals are for this. And now I hand you over to Seung-Kyung.
Our research project proposal is to use some bi-manipulation with two hand. You know, PR2 has two hands, and yesterday when you calibrate, the PR2 hold the checkboard with just one hand and doing some calibration. But maybe next year we can do that with that big checkboard holding with its two hands. So our goal is to just performing this bi-manipulation with two hands. Some cases like that when you can hold some object with only one hand. So it is a challenging problem because we have to maintain the contact between the object and the end effector, and also we have to consider in the first closure of the object that it does not drop or just moves. But we have to allow there's some rolling and sliding between the contact point of the end effector and the object if it is required or it does not matter. And as you know, when we hold up some object with our two hands, we just form a cross chain and it will be a redundant system. We have some previous results on planar case. Here is a video by another PhD student. Our goal is that L-shaped object to manipulate that L-shaped object to follow a certain arc. So we just assume we can estimate the friction required to manipulate that object to follow arc, and these two mobile robots just changing their configuration to that it can compensate the estimated friction. So when it goes a little bit far away from the arc, it's just reconfigured, and then if you can go to the far away arc, it just keep going. So our goal is to, in control aspect, we are considering to use some redundancies to maintain contact and some trajectory following of the object. and we need to develop some nonlinear feedback controllers. And in planning aspect, we can partition the configuration space that satisfy our all constraints and construct a compact graph of that connecting these configurations, and we can use search-based planning algorithms. Thank you.